Let's come to this one here. Rotation of this. Very simple idea-based question I picked up to explain the concept. I'll read the question now. A source laser S, a receiver R, and a fixed mirror F all lie on an arc of a circle of radius r 0.5 kilometer. The distance between the source and the receiver is d, so that also given. At the center of circle there is a small mirror, center of circle. Okay, this is he's saying center, which is rotating with an angular speed omega. Find the smallest value of omega is if it is seen that the source shoots a laser pulse which gets reflected at m, then gets reflected at f, and finally gets reflected at m to be received by the receiver. What's the basic idea? If the mirror rotates by an angle theta, how much the incident ray will rotate? How much the reflected ray will rotate? If the mirror rotates to an angle theta, how much reflected ray will rotate? Shall we say 2 theta? Can you recollect those ideas? That is what you have to apply here. Yeah, okay, no, get into the problem. Say from principle of reversibility of light, the ray which is sent here gets reflected, will fall on the mirror. Again, it will retrace, it will come here. There's the thing. So the moment here the ray goes, get reflected. So it starts moving. So by the time it arrives here, the mirror, if it rotates, so that what will happen, the reflected open should come here, should not go path ms, should take the path mr. For that, I should rotate the mirror. So what is that angular velocity is asking? Okay, we'll start with this. Let me not draw many diagrams here only. So can we calculate that angle theta? Sine theta, or for small angle theta, d by r. So d is how much? 0.5 by radius is how much? 0.5 into 10 to the power of 3. So this will become 10 to the power of minus 3 radian. Okay, I'll make it theta very small. We'll write in terms of this one. No, so this is thing. So what should happen this one? The reflected ray, so it should and they should be reflected symmetrical. So it will be like this. Take theta. How much the reflected ray should be rotated to an angle theta. For that, how much the mirror should be rotated? Theta by 2. This should be the position of mirror. The ray which is incident after reflection should pass through this one. So what should be the normal? This should be the normal now. Earlier this was the normal. So what will happen to the ray? This is a receiver. and there's a small mirror. Sir, it's a plain mirror only, so don't bother. Or it's a curved mirror, let it be small surface, so it'll get reflected normally. We need not to bother. Sir, is it a plain or a curved one? Let it be curved one only. But it will be silver. So if a ray passes through, this will be like a normal, no? Because any ray coming from this. Let's get into this one here. So now how much I should. So what is asking, that angular velocity is what is asking. So how much the reflected ray? What is the time? So what actually all of you able to understand? So the ray what pen is inside. By the time it goes from C to F, F to C, the mirror should take this position. Getting the idea? By the time the ray what pen from here, from C to F, F to C, the mirror what pen should take this particular position. So we know time. So what is the time? Time of traverse. This should be equal to the distance will be CF plus FC by speed of light. This should be R plus R by C, 2R by C. Then what should be the angular velocity of the mirror? It should be equal to delta theta by delta t. How to calculate delta theta? I should rotate it through small angle. Let me take some other angle. This one. How to calculate this phase angle? How much I should rotate the mirror? Theta by 2. Because this will become normal, so this will be theta by 2, theta by 2. If the mirror rotates by the angle theta, the reflected ray will rotate by how much? Theta by 2. How much the reflected ray? So earlier, the reflected ray, what will happen? Will trace out here. So the reflected ray should be rotated by how much? Should be theta. Then the mirror weapon should be rotated by theta by 2. So what should be the angular displacement? Should be theta by 2. How to calculate theta? We have here. Substitute that, we'll get the fine. Simplest idea. So I'll give the answer. Check it now. This will be
150.
one.
150.